Okay, this is 17.2, in particular, how to use the Hardy Weinberg equations. So on this slide here, you need to know these two equations here, and you're going to need to know what the letters stand for. Okay, when we do the gizmo, that will kind of help you a little bit more too, to reinforce this, but this is what you need to know. Okay, so an example of, or what you use these equations for, is to calculate allele frequencies. Allele frequencies, and then so you calculate it for one generation, and you calculate it for the next, and then you look to see if the allele frequencies have changed, and if they have, evolution's occurring. If they haven't, evolution's not occurring. And when we say they change, you have to obviously do more than just 2 generations. You have to do quite a few to see if there's a pattern, because it, it can fluctuate a little bit. But if you see a large change, then probably natural selection or something is going on. Okay, so go ahead and read the information about the problem. You can stop it and then start it back up. Okay, so what we have to calculate first are the frequencies of the big S and the little s alleles. So first of all, the big S from our equation is going to be equivalent to the P. Okay, the little s is going to be equivalent to the Q. Okay, and then on question 2, big S will be the P squared. Big S, little s would be the 2PQ, and little s would be Q squared. And so I'm going to show you how to calculate for this on the next slide. Okay, you might want to get a piece of paper, or you can just write on your notes, however you're doing this. Okay, so, the question said, what are the frequencies of the big S and little s alleles if little s is 36 over 10,000? So that's given to us, right? And we said that little s, I'm going to do a cursive one, okay? Do it in blue. Little s is the same as Q squared, right? And then in the problem it's given is 36 over 10,000. So the first thing we need to do is change that to a decimal. And it comes out to 0.0036. Make sure you check your calculator, because I'm doing this in my head a little bit. All right, so Q squared is the same as little s, right? So that's our Q squared. Now, if we know that Q squared is equal to 0.0036, what is Q going to be? That's right. If you get the square root of Q squared, that'll tell you what Q is. So if Q squared, square root of Q squared, the same as the square root of 0.0036, Q is going to equal what? That's right, 0.06. Now the frequency of it, we have to change to a fraction, because it asks for the frequency of the S allele. That will be 6%. Okay, so the frequency of the S allele, little s, will be 6%. I'm going to put here FREQ for frequency, because that's what it asks for. All right? Now, if little s is 6%, which is Q, right? That's Q. So if Q equals 0.06, P is going to be what? 1 minus Q is P. So P equals 1 minus 0.06. So P equals 0.94. And then the frequency of P is 94%. So that's question number 1. Okay? So here's our 2 answers, right here and here. Okay? All right. Then on question 2, it says, what's the frequencies of big S, little s, and little s? So now we have to use our other equation, P squared, 2PQ, and Q squared, right? So we need to figure out the frequencies of big S. All right. Now big S is the same as what? That's right, P squared. And then big S, little s is the same as 2PQ. And then little s is the same as q squared. And we had already figured out q squared earlier, didn't we? And if you remember, that was 0.0036. But the frequency, I want you to change that to percent, is 0.36%. So that's the frequency of little s. Okay? So if q squared is 0.36, and from the other slide, here we go, what was p? P was 94%, or 0.94, right? So p squared, here we go. So p squared equals 0.94 squared, doesn't it? And I believe, what is that? It's going to be 80 something, 0.88. So I'm just going to put 0.88. I'm not sure on after that because I know that it'll be at least that. So I'll put 0.88, right? Where's my calculator? I think that's right. 0.88. Hold on, let me. Okay, that's 0.8836. Okay, so that's our p squared. And p squared is the same as what? That's right, big S. Then lastly, we have to figure out 2pq. So 2pq is the same as big S, little s. And so we multiply 2. P was 0.8836. And, excuse me, that's a 6. And then Q, oh no, my bad. What was P? P was 0.94, wasn't it? Okay. P was 0.94. And then what was Q? Was Q 0.0036? Let me go back to this one. Q was 0.06. Okay, Q was there. And then what does that equal? Let's see. So that will equal 0.1128. Okay, now all of these are frequencies, right? So we need to change them to percents. So that would be, I'm just going to round it off to 88%. And this one will be 11%. Okay, so S is going to be 88%. 2pq is 11%. And then q squared, or little s, is 0.036. So the way you can check that is add all three of these together, and they will equal 99.36. So that's very, very close to 1, isn't it? Or to 100. Now the last question on there, said what? It said, what percentage of people in total is likely to be carrying the S allele, whether they know it or not? So what information do we need? So carriers of the S allele, just having it, right, would be our q squared plus our 2pq people. Okay, and if we go back to our slide, what was our little s was 0.36. Okay, so we had our little s, our q squared, plus our 2pq. And that was 0.36% plus 11%. And that gives us 11.36% as our answer. Okay? I'm going to stop this here.